So what I want to talk about here is the derivative of the natural logarithm functions. It's kind of adding yet another functions derivative to our toolbox. But to do that, we need to talk for just a minute about a relationship with inverse functions, because there's a really straightforward relationship between the derivative of a function and the derivative of its inverse, right? And hopefully you kind of see where I'm going with this, right? Because the exponential function and the logarithm functions are inverses, right? Hopefully this will let me find that really easily just by applying the formula. All right, so I don't want to go into a lot of effort, right, rehashing inverse functions. The one thing you really need to have in mind here, the one property we're really going to need, is if we have two functions, f and its inverse, right, then f of f inverse of x is just x. Okay, so that's how we can use this, right? So let me write that again. F of f inverse of x equals x. Okay, now hopefully the first thing that just jumps out at you here is what we're looking at is the composition of two functions. And we have a way to differentiate the composition of two functions. It's called the chain rule. Right? So the chain rule says that the derivative of the left side is f prime of f inverse of x times, and the notation is going to get a little awkward here, the derivative of the inverse equals, and the derivative of the right side, that's just 1, right? Derivative of x is 1. Now, solve this for the derivative of the inverse, and we'll have our formula, right? So I'm just going to divide by this part. F inverse of x prime equals 1 divided by f prime of f inverse of x. Right, so hold on to that, and we're going to use this to get the derivative of the natural logarithm function. So now we can get to the derivative of the natural logarithm really quickly. Right, first, I'm going to let f inverse of x equal the log of x, which means f of x equals e to the x. I have to pick them this way, right? Because it's the logarithm that I want to find the derivative of, and my formula tells me what the derivative of the inverse is, right? So the formula says the derivative of the inverse of x is 1 over f prime of f inverse of x. Okay, so what is f prime? Well, f prime we know, right? F of x is e to the x, so f prime is also e to the x, which means the derivative of the inverse is 1 over e to the log of x. But e to the log of x, right, they're inverse functions, right? So e to the log of x is just x. And that's it. There's my derivative of a natural logarithm. Also a fairly straightforward function. Right, and I've written that out here. Right, the derivative of the natural logarithm is equal to 1 over x. All right, so let's look at some examples. Let's see if we can use this. Take a look at this thing. Right, let's see. I've got the logarithm of 3 to the x. Remember, anytime we hear that word of, right, I'm immediately thinking I have a function composition situation here. And when we're composing functions, we differentiate using the chain rule. Right, so you've probably gotten used to this by now, but because we've got a new thing here, let's go back and write this out in a little more detail. I'm going to let g of x equal the log of x, and I'm going to let h of x equal 3x. All right, so then h prime of x is 3, and g prime of x is 1 over x. All right, so f of x is g of h of x, right? Which means f prime of x is g prime of h of x times h prime of x. All right, so h of x, that was 3x. So this is g prime of 3x times h prime, which is just 3. All right, so g prime, remember, that's this here. So I'm going to put 3x into that, and this is 1 over 3x times 3, which is just 1 over x. All right, well, that's kind of an interesting thing to see, right? Putting that number in front of the 3, putting that number in front of the x inside the logarithm didn't affect the rate of change, right? Didn't affect how quickly our function is changing relative to the standard logarithm. Now, let's look at this another way, right? We've got the log of 3x. Well, remember we've got we've got logarithm rules, right? And there's a logarithm rule that says I'm just going to rewrite it again. F of x equals the log of 3x. We've got a logarithm rule that says this is the log of 3 plus the log of x. So let's try differentiating it this way. Now f prime of x equals the derivative of the log of 3 plus the derivative of the log of x. So what's the derivative of the log of 3? Well, the log of 3 is just a number. It's a constant. The derivative of a constant is 0. Plus the derivative of the log of x, that's 1 over x. And that whole thing is just 1 over x. So awesome, we get the same answer either way, which is what needed to happen, right? But when we're differentiating these logarithms, you're often going to have options, right? Based on the manipulations we can do with those logarithm properties. Okay, so try doing this one, right? Try doing this one and see what you can come up with. Right, so once again, there's two different ways we could approach this. Right, first it's using the chain rule. Right, the chain rule says f prime of x equals 1 over x squared times the derivative of x squared. Okay, the derivative of x squared, that's 2x. So this is 1 over x squared times 2x. We can do a little canceling now, right? The x's cancel there, and this is just 2 over x. Okay, let's try it again. Right, this time come at it the logarithm way, right? One of our logarithm properties says I can take that 2 and bring it out in front. So I can make this f of x equals 2 log of x. Now let's differentiate. F prime of x is the derivative of 2 log of x. Now I'm going to use a derivative property, right? We have a derivative property that says I can take that 2 and bring it out in front. So this becomes 2 times the derivative of the log of x, which is 2 times 1 over x, or just 2 over x. You know, look at that. Excellent. We did get the same thing either way. Which method should you use? Whichever one comes to your head first, right? Frankly, I think it's a little easier. I think that it's easier if you can do a little simplifying with the logarithm properties first, but that's just me. You're going to get the same answer either way. Okay, so again, there's not a whole lot new here. Right? I mean, we have one new definition, one new function we know how to differentiate. But to do that, we're still just mixing and matching these rules that we already knew. Product rule, quotient rule, chain rule, and all these derivative properties, derivative rules. All right, so where are we going to go next? We've got one more thing to do in our discussion of exponential and logarithm functions. We need to figure out what happens when we have a base other than e.